Web Service Engineering Spring 2021, Team 3 Programming Project, Matchmaker. Hi, my name is Kim, and I'm going to demo the data part of our project. We decided to use MySQL as our database because we thought it would be easier to use a relational database for the project. We set up 3 main tables. The first is the gamer table. It contains the gamer ID and properties related to the gamer, such as their skill level, the region where they live, their language, personality type, the game they prefer, their name, and age. All gamers that use the app are entered into this table. We wanted the gamers to be able to add friends as well, so we created a table to hold the gamer friends. There would be a record for each friend for the gamer in this table. We also wanted a feature for the gamer to be able to create groups of friends based on the different games that the gamer plays. This is the gamer group table, and it contains the main gamer ID along with the friend ID and a group ID. There is a record for each friend in each group for the gamer in this table. So we have about 1,000 rows in the gamer table, and you may wonder how we got all this data. Well, we discovered an easy way to generate the data by going to a website called Mockaroo.com. This site let us generate up to 1,000 rows of realistic test data in CSV, JSON, SQL, or XML format. And then we could download the data and upload it to our database. This is the sample form, but you can change any of the field names and the field types. You can use formulas when creating the data at random. And then you can download the file into several different formats. This is the schema that I created for our Gamer Match application. These field names relate to the field names set up in the gamer table. And I entered descriptions that could be used when the data was generated randomly. I picked a CSV format, and then I downloaded the data, and I uploaded the data into the SQL database. We also hosted our database on a site called Cloud Clusters. So this way we did not have to have MySQL set up locally on each of our computers.
Hi, my name is Eric Acevedo, and today I would like to talk about our Matchmaker web application that our team developed for this course. As you can see, this is the homepage where users would land on when they first access the application. They have the ability to search for an existing profile by using a gamer ID or create a new profile. So to demonstrate these functionalities, you click on the input field. Here you can type in your existing gamer ID. Click on the search button, and this would land on the player info page demonstrating the gamer ID, an edit icon, the gamer's information, along with their friends list and a groups list. But let's say, going back to the beginning, let's say that the user does not have a player info profile at all, and therefore we're going to go ahead and create a new one. So when we click on the Create Player Profile button, the user will land on this form where I can insert my information. Let's create a new gamer ID, let's say 5,000. You put in your age, your minimum wait time. Let's go ahead with casual skill level, region, let's say Southeast US, language English, personality type casual, and I will say Overwatch for my game, and let's say competitive mode. So once everything is populated, I can click on the submit button and my player profile will be created. As you can see now, I have my gamer ID at the top. I have my information displaying, but now as you can see, I don't have any friends and I don't have any groups. And therefore, let's go ahead and find some friends and create some groups out of our friends list. So if you click on search friends, we can select which skill level you're looking for. Let's say competition level. You can choose your personality type, and you can choose which game, which in this case I will choose Overwatch. And then here are the results. I can select several of these players to become my friend. So in this case, let's select 3 of them. Let's select the first one. Let's select Yovanda, and let's select Doria. And when you click on Add Friends, they will be added to my friends list, as you can see right here. And if you want to know more information about these friends at a later time, you can go ahead and click on any of them, and it will display the information for this particular friend, as you can see. So now that I have my 3 friends on my friends list, let's say I want to create an Overwatch group to play with them, and therefore I'm going to go ahead and create a group. So I go ahead and click on Create Group. I will call this group name Overwatch Team. I select my friends who are going to belong to this team, and when I click on Create Group, all of them will be added to this particular group into my friends list. As you can see, there we're displaying the group name along with the friend ID for each one. And once again, you can also click on this and it will show information for this particular gamer. And to finish off, if I want to edit my profile, I can click on this pencil icon. And let's say I want to simply update my language. I want to play in Spanish. And let's say we will stick with Overwatch and Quick Play. And so now, as you can see, my language has been updated along with the game mode. This pretty much concludes the demo for our web application, and next I would like to spend a little bit of time explaining our project structure and the technology that we use to create this web application, which in this case we used React. So this is our Matchmaker UI project, and we use React, which is a JavaScript library used to create UI components. When you import the project from GitHub, you will see all of these files on the left-hand side. And in order to set up the project, you run npm install to install all the dependencies that are present within package.json. Once you have installed them, you can execute npm run start to start executing the project locally on your local machine. If you want to build from your local machine, you can run npm run build command, or you can run npm run test command to execute your test cases. The parent component is the app component at the very top. Here is where we are saving several attributes that can be used throughout the entire application, and we're saving them using Context API. We have several methods that can be invoked from anywhere in the application to update the states within the store. And then here in the app component, we have a context provider that is feeding all of these different attributes down to the inner children, or in other words, the consumers. And here we are explicitly dictating what are the routes within our application. And so, for example, here we have the home page, which we demonstrated a little bit ago. And at the very top, we have our constructor. At component did mount, when this page is mounted onto the screen, we are resetting all of these context values to their default values. We have a couple of methods here where we are setting the flag for the search modal and the state for the search modal. And then at the bottom, we have a render method, which is connected as a consumer to Context API. And we are rendering all the images that are on the home page here, along with the text field that when you click on it, it brings up the search modal, along with the add player button at the very bottom, which takes you to the form page so that you can create your player profile or edit it. So this is basically how our components are structured, and this is how our project is structured. We have all of our components within the components folder. We have all the endpoints that are being invoked between the user interface and our backend service in the API endpoints JavaScript file. We have all of our image files within this images folder. And each component has its own set of test cases. And in this case, we're using React Testing Library. This is how we have been able to create integration tests, which is basically checking to make sure that everything that we expect to see on the screen is actually being rendered. And so as a result, in order for us to run our test cases, we simply execute the npm run test command, and it will execute all the test cases for all of the components, as you can see here in a little bit. I have clicked on the A button on the keyboard to execute all of the test cases that are present within my project. And as you can see, these are all the different test case files that will be executed. And as you can see, they all pass. This basically concludes our presentation. Thank you very much for your time and attention, and I hope you have a good day. Thank you.
Hello, I'm Srikanth from Krishna, and I'll be presenting Spring and REST API as used in our application. To start off, to give an overall picture of where Spring is used, here is an overview of the architecture. The browser is talking to an AngularJS app which is running within a Node.js container. This AngularJS application is talking to a Spring Boot application running in a Tomcat server. The Spring Boot application itself speaks to MySQL server, which serves as the database. The Spring Boot application is exposing REST APIs that is consumed by the AngularJS application. And this is the overall architecture, and now you know where we use the Spring Boot application as the middle tier or the business logic layer of our application. What is Spring? Spring is a Java application framework for Java based web applications, which is based, the whole of Spring is based on the design principle of inversion of control and dependency injection. Inversion of control means the components are configured from outside and via configuration files and not from within the application itself. This gives great flexibility for application developers to extend their application features at runtime. Dependency injection is a more involved subject. Briefly is when an object that can be injected or created from the outside can be injected into the application via these many ways of doing them, which is setters, constructor or service lookup, the details of which are beyond the scope of this presentation. Spring Boot is a new member to the Spring family of frameworks. Spring has been in favor of configuration, where a lot of configuration files are required to get it up and running. However, Spring Boot approaches to have convention over configuration, and this has made Spring Boot a favorite among developers because we can develop applications very fast and quickly. Spring Boot also provides a range of non-functional features like security, metrics, health checks, etc. And since Spring Boot is part of the Spring family, you can still use all the other annotations and other features of Spring like database access and security and such from Spring itself. What is REST? REST stands for Representational State Transfer. What it basically means is we use HTTP methods in our APIs. For example, when you have get to a particular URL, in this case, let's say you have get/gamer/1, the convention says you should be able to get the data of gamer with the ID 1, and that serves as an API for getting gamer data. Similarly, if you want to delete a gamer, you would use delete/person/1 or delete/gamer/1, which the user would be expected to call if he wants to delete that particular gamer or person. How do we put our develop REST API in Spring Boot? Like anything in Spring, it's based out of an annotation. In this case, the annotation is at REST controller, and you have to pass in a request mapping, which is what's the context root for this particular API. In this case, we are saying /matchmaker. And for this particular API that is exposed, we are saying the method has to be post, which is at request mapping, request method.post, and the path is /person. So the overall API would look like, for example, if Tomcat is running on 8080, it would be localhost /8080/matchmaker/person. And if you make a post request with the request body containing the person object in it, the Spring Boot server will do the required wiring to expose this particular API as a REST API. Another entity we use from Spring Boot is called CRUD repository. CRUD stands for create, read, update and delete operations, and this abstracts all of these operations from the database. And in our case, for example, I have a CRUD repository with the object gamer, integer. This means the gamer with the ID of the gamer integer will be exposed without much code for all the CRUD operations in the database, which means the CRUD repository interface provides me with save, find all, find by ID, etc. operations of the database. This is a very easy way to wrap objects that are in the database and expose all the methods provided by JPA in one class. What else are we using? For build and deployment, we are using Gradle, and Spring Boot has an embedded Tomcat server, so we don't have to worry about the Java container. It's already there. By default, it's Tomcat, and we're using MySQL as the database. Thank you.
With this team project, we decided to use a CI/CD for faster development and to reduce regressions within each commit. Every commit's important, and it's important to make sure that we're never introducing bugs, or at least introducing bugs as infrequent as possible. As you can see by the green checks, that means that all tests passed and the Docker container built successfully and was then deployed to our Azure environment. We use YAML files, Docker containers, GitHub Actions, and Azure for our deployments and CI/CD process. If any tests fail, then the build stops immediately and returns an error and would not be deployed. If the tests all are successful and then the build is successful as well, at that point the GitHub action would then deploy the new Docker container to our Azure environment into test and eventually to production. This is a very important process. It's very, very helpful and beneficial when implemented correctly.
This concludes our presentation. Thanks for watching.